Good morning. My presentation is about NLP based sentiment analysis for social media data. The main goal of this work to understand how sentiments can be classified from social media text and why modern contextual models perform better than traditional machine learning approaches on such kind of data. Every day, social media platforms generate a huge amounts of text. That text contains opinions about products, services, public issues, and events. Sentiment analysis tries to turn that raw text into structured insight by classifying into positive, negative, and neutral. The difficulty is that social media language is very different from formal written language. It is usually short, informal, and noisy. People often use slang, abbreviations, emojis, hashtags, and spelling mistakes, and because of that, it is not a simple text classification problem. So, in this work, the idea is to compare a traditional NLP pipeline based on TF LDF and SVM with a transformer based model, Roberta, using a benchmark dataset. So, why does all of this matter? Why does sentiment analysis matter? This problem matters because online opinion has become a major source of real world feedback. For example, companies use customer comments and public reactions to understand how people feel about products or services. Governments and organizations can also use large scale opinion analysis to monitor public response to events or social issues. The reason sentiment analysis is valuable is scale. If there are thousands or millions of comments, manual review becomes unrealistic. So, automation here is necessary. But automation alone is not enough. The output also has to be reliable. If a model misclassifies sentiment, the decision made from that data can also be wrong. That is why improving sentiment analysis is important in practice, not just academically. The central problem is that social media text is difficult to interpret correctly. Traditional text classification methods work reasonably well when the language is structured and formal. But social media posts are often short, informal, and highly variable. A single tweet may include abbreviations, emojis, sarcasm, or incomplete grammar, and all of that affects the meaning behind it. So the real challenge is not only assigning a class label, it is representing meaning accurately when the input is noisy and context dependent. That is why this work focuses on comparing models that process language in very different ways. There are several challenges behind this task. The first is limited context. Because tweets are often short, the model often has very little information to work with. The second is noise. Social media language includes misspellings, slang, abbreviation, and symbols. That makes the text harder to process. The third is context dependence. Sentiment is not always contained in individual words. Very often, the meaning comes from the full sentence. And finally, the type of language used in tweets is different than formal text. So models that perform well in one setting may not perform equally well here. These challenges are exactly why model choice becomes so important. This work contributes in a structured way rather than by proposing a new algorithm. First, it presents a complete NLP pipeline for tweet sentiment classification. Second, it compares two fundamentally different approaches, a traditional baseline model and a transformer based contextual model. Third, it uses a benchmark dataset so that the evaluation is fair and standardized. And finally, it goes by beyond simply listing scores, it also explains what those results mean from a practical NLP perspective. The objectives are straightforward. The first objective is to build clear sentiment analysis pipeline for social media text. The second is to compare a traditional baseline model with a transformer baseline model. The third is to use a benchmark dataset for fair evaluation. And the last objective is to analyze the results and explain what they mean in practice. So, overall, the project is designed not only to implement a workflow but also to interpret model behavior. In the literature, traditional machine learning methods such as SVM have been widely used for sentiment classification. They are efficient and often provide strong baseline performance, but they rely mainly on manually constructed text representations such as TF and LDF. And more recent transformer based models like BERT and Roberta improve performance because they capture contextual meaning instead of relying on isolated word features. There are also tweet specialized models such as BERT Tweet, which are trained more directly on social media language and can therefore adapt better to that domain. So, this project is positioned as a benchmark based comparison between these generations of approaches, traditional feature based NLP on one side and contextual transformer based NLP on the other. This is the core workflow of the project. The process begins with tweets taken from the tweet eval sentiment dataset. Then pre-processing is applied. That includes normalizing mentions, removing links, and preparing the text for tokenization. After pre-processing, the same cleaned input is sent into two separate modeling paths. The first path is the baseline approach. TF-LDF with SVM in that path, the text is transformed into numerical features based on word importance, and those features are then used by the classifier. The second path is the advanced approach, which is Roberta. Instead of using handcrafted feature representations, Roberta processes the sentence in context and produces a sentiment prediction based on contextual language understanding. Both models then output one of three sentiment classes, either positive, negative, or neutral. At the end, both are evaluated using the same metrics. The point is important because it makes the comparison controlled and fair. If I simplify the workflow, the pipeline is basically this. Tweets come as input, the text is cleaned and prepared, the same processed text is passed into two different model architectures, and then the outputs are compared using common evaluation metrics. So the difference in results is not because the models were given different data, it comes from the difference in how each model represents and understands language. The dataset used in this project is the Tweet Eval Sentiment dataset. This is a benchmark dataset commonly used for tweet sentiment analysis, which makes it a strong choice for fair comparison. The task here is three-class classification, the positive, negative, and neutral. The dataset is also divided into training, validation, and test sets, which is important for proper experimental setup. The training set is used for learning. The validation set supports tuning or checking performance during development. And the test set is used for final evaluation. So this slide establishes that the comparison based on a recognized benchmark and a standardized evaluation setup. Before classifications, the tweets are cleaned. User mentions are normalized so that the model is not distracted by specific usernames. Links are removed because they usually do not carry sentiment value by themselves. Then the text is prepared for tokenization. The before and after example here is useful because it shows the role of pre-processing very clearly. A noisy tweet containing a user mention and a URL becomes a cleaner input sentence that still keeps the main semantic content. The point of pre-processing is not to make the data perfect, it is to reduce unnecessary noise while keeping the sentiment signal. The baseline model in this work is TF-LDF combined with SVM. TF-LDF stands for Term Frequency Inverse Document Frequency. It converts text into numerical features by measuring how important words are within a document relative to the full dataset. Then SVM, or Support Vector Machine, uses those features to classify the text into the sentiment categories. This is a strong traditional baseline because it is simple, efficient, and widely used in text classification. But it also has an important limitation, which is that it mainly relies on word level importance and does not truly understand context across the sentence. The advanced model is RoBERTa, which is a transformer-based language model. The key difference is that RoBERTa processes words in context. It does not just look at whether certain words appear, it models how words relate to each other across the sentence. That matters a lot for social media text because sentiment is often dependent on the full phrase and not on one isolated word. The comparison shows at the bottom of the slide captures the main idea well. Traditional models depend on word-based features, while RoBERTa uses contextual language understanding. That is why transformer-based models are generally expected to perform better in this task. Evaluation metrics. The models are evaluated using precision, recall, and F1 score, with macro averaged recall used as the main benchmark metric. Precisions tell us how many of the predicted labels are actually correct. Recall tells us how many of the true cases are correctly identified, and F1 score balances precision and recall. Macro averaged recall is especially important because it gives equal importance to all sentiment classes. That makes the comparison more balanced, especially when class distributions are not perfectly even. For benchmark results, these are the benchmark results from TweetEval. The traditional SVM baseline reaches 62.9, RoBERTa base reaches 71.3, and the RoBERTa version retrained on Twitter data reaches 72.6. The important thing here is not only that RoBERTa performs better, but also that the gap is quite large. Moving from 62.9 to 71.3 is a major performance increase, not a minor improvement. Then there's a smaller but still meaningful gain when the model is adapted further to Twitter-style language. That suggests that contextual modeling helps a lot and domain-specific adaptation helps even more. These results tell us something important about model design. The large gap between the SVM baseline and RoBERTa shows that contextual language models have a clear advantage on short, noisy social media text. The reason is that traditional feature-based methods treat text in a more shallow way, mainly through word importance. RoBERTa, on the other hand, captures meaning through context. The additional improvement from the Twitter-adapted RoBERTa also shows that language domain matters. A model trained more closely on the style of tweets perform even better. So the interpretation is very clear. Better contextual understanding leads to better sentiment classification performance. This slide is important because it adds balance to the discussion. On the limitations side, the results are benchmark based, so performance may vary on other datasets or platforms. Social media language also changes over time, which means model behavior may shift as language evolves, and some difficulties such as sarcasm or ambiguity still remain challenging. On the assumption side, this project treats TweetEval as a reliable benchmark and uses macro averaged recall as the main comparison metric. And on the implication side, the results support the use of transformer-based models for practical sentiment analysis tasks. They also show that domain-specific pre-training can improve classification's quality further. So this slide helps connect the benchmark findings to practical use while still acknowledging the boundaries of the work. To conclude, This work presents an NLP framework for sentiment analysis on social media data and compares a traditional baseline with a transformer based approach. The comparison shows that Roberta clearly outperforms TF-IDF with SVM on this task. That supports the broader conclusion that transformer-based models are more suitable for short, noisy, and context-dependent social media text. For future work, there are a few natural next steps. One is to reproduce the experiments directly rather than only relying on benchmark reported results. Another is to perform deeper error analysis, especially on difficult cases such as sarcasm. A third direction is to explore tweet specialized models such as bird tweet. Thank you for listening to this presentation. Have a good day.